All right, we're going to talk about properties of rectangles today. We've already discussed parallelograms and then polygons. A rectangle is a parallelogram with 4 right angles. It's a special parallelogram. What we're going to learn today is that the diagonals of a rectangle are congruent. So the fact that it has 4 right angles is illustrated right here. And the fact that the diagonals are congruent is illustrated here. And we are going to mark that if the diagonals are congruent, we also know that since it's a parallelogram, what else do those diagonals do to each other? Bisect each other, right? Cut each other in half. So if they cut each other in half and they're also equal in length, then that means all the pieces here are the same size. So then AD is congruent to BC, and all those bisected segments are the same size. Those 2 bisected segments are cut into equal parts. A rectangle has 2 lines of symmetry, vertical and a horizontal. And the diagonals make 2 pairs of congruent triangles. So if we went this way from the left upper corner to the right lower, we just made 2 congruent triangles. And on the other one, we can go the other way and make 2 congruent triangles. So these are congruent because they're both right triangles with the same hypotenuse, and the opposite sides are congruent as well. A rectangle also has the properties of a parallelogram. Opposite sides are parallel. So the top side will do double arrows. Those are parallel. The left and the right sides are parallel. Top and the bottom, left and right. All the angles are congruent because they're all right angles. I'm not going to make a picture for that. We've already got it right up there. And opposite sides are congruent, so we would know that the left and the right side have the same measure, and the top and the bottom have the same measure. Okay, anybody still need this page before I flip or go on? Okay, yes? All right, I'll wait. Thank you. Okay, now I already did this. I forgot I had next page was some of this stuff already on it. We already marked this up. You have this already. You have that these are congruent. And consecutive angles are supplementary. Well, that makes sense because they're right angles. We know the diagonals bisect each other. Okay. Let's go ahead and put that into this picture. So I'm going to show the 2 diagonals drawn. And then the slashes again that we drew up above, which would mean that all of these segments are equal because the diagonals cut each other in half and they are congruent to each other. Now, an important concept is that the diagonals do not bisect angles unless the rectangle is a square. So this rectangle over here, when you draw in a diagonal from a corner to a corner, I'm only going to do one of them for this to show you something. That diagonal did not cut the corners in half. So these aren't 45 each. This one is bigger than this one. They are different. But there are congruent ones down here. Remember, alternate interior angles. So if that big one up here, that would be equal to the one down here on the left side of the diagonal. And the double arced one would be congruent to the one on the right side of the diagonal in the bottom corner. And of course, these would add up to 90. Okay, because the corners are right angles. I'm going to show you that the diagonals do not bisect the angles unless it's square. If I show you here some angles that are congruent, I could tell you that this angle is congruent to this angle. And these two down here would be equal to them as well. And that's because this thing is isosceles, and so is this. So the base angles would be equal. But then you've got some other triangles that are congruent. These two angles are congruent to each other, and these two angles are congruent to them. So you've got a bunch of 4 sets of angles that are equal in here, and then you've got 4 more sets of angles that are equal going the other way. Okay, so you got a bunch of congruent things in here. You also know the vertical angles are congruent, so there's a lot of stuff that you can do with a rectangle and figure out numbers, depending on what you're given. So here are some examples of what you could do. In example 1, it says if the measure of angle BEA would be this angle here, 62. Find the measure of angle BAC. BAC would be this angle. Okay, if I'm trying to find that angle, how might I do it? Well, I kind of gave a hint just a minute ago. These are little isosceles triangles, and this angle is equal to this angle. So what could I do to figure out how big those two congruent angles are? I only know one angle in the triangle. Cadence? Perfect. 180 minus 62, that's 118 degrees. And then I would take that 118 and divide it by 2, just like Cadence said, which would give me 59 degrees. So that would tell me that the measure of angle BAC, which is that corner right there, is 59 degrees. That other angle over here, which is ABC, would also, or ABE, is also 59. They only asked for one of them. Okay, example 2 has got to do with something else. It's not the same, it's not angles. So if you would prefer to have a separate picture for that, then you can redraw the diagram. I'm going to try to do that fairly quickly. Okay, I'm going to put label it BCDA, and then it says AE, A to E, well E is here, is 36, and C to E is 2x minus 4. Well, those are, that's a diagonal. A to C is a diagonal, and those two pieces are equal because the diagonals are bisected. All right, so 2x minus 4 equals 36. We would add 4. We would have 2x equals 40, and divide by 2 to get x is 20. Okay, and we may wish to draw another same diagram for example 3. I'm not going to be too picky about my drawing. I want to label it the same way. And I only did that because we were using the same picture 3 times. There's an E in the middle, and it says the measure of angle DE is x plus 12. That would be here. And the measure of angle CDE is 3x. That would be that angle right there. What do we know about those two angles? What would it be true that would help us find x? Oh, that's very good. You used the word we haven't used in a while. Say that again. They're complementary, which means they add up to how much, guys? 90. Yep, there's a corner there. A rectangle has right angles in the corners, so those angles add up to 90. So 3x plus x plus 12 equals 90. That would be our equation to solve. Add your like terms. 4x plus 12 equals 90. Subtract 12. 4 times x is 78. And then divide by 4. 19.5. Yeah, I was going to say, I think it's a decimal. X is 19.5. All right. We have 1 second. We're going to prove, I think, something next. Okay, to prove that you have a rectangle, there are a couple of methods. Proving that a parallelogram is a rectangle, the diagonals of a rectangle are congruent, and the converse is also true. If a figure is a parallelogram and the diagonals are congruent, then it's a rectangle. So, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. All right, so we would have to show first that it's a parallelogram, and second that its diagonals are congruent. So in the coordinate plane, you can use the distance formula, slope formula, and properties of diagonals to show a figure is a rectangle. This first example is telling us to use slopes. I will use the slope formula once, and then I will use the grid to get those slopes the rest of the time. So first, quad ABCD has the following vertices that we want to label. So A would be here at -3, 0. B is at -2, 3, which is up there. 4, 1 is where C is, and 3, -2 is where D is. The slope of segment AB. To find the slope, you subtract the y's and the x's. Y's first on top, x's on the bottom, and you do it in a consistent manner. So if I'm going to do point AB, I'm just going to start with the y's. 3 minus 0 over -2 minus -3. 3 minus 0, of course, is 3. -2 minus -3 would be -2 plus 3, and that's 1. Now, you can keep doing the subtraction of the points and find the slopes, or you can go over to the grid and count. Now, watch how I could have found that 3 over 1. You can go from A to B by going up 3, right 1. That was a lot faster than subtracting those numbers, but you need to be able to do either way. The slope of AD. Now I'm going to go from A to D, and I'm going to count on the grid. I'm going to go down 1, 2, and right 1, 2, 3, 4, 5, 6. That's -2 for the down 2, and right 6 is +6, and then you need to reduce that to -1/3. You see these numbers? 3 over 1 and -1 over 3. These are opposite reciprocals. Okay? I want you to notice that those are opposite reciprocals. I'm going to continue on now and find the slope of CD, and I'm just going to go over here and count. To go from D to C, I would climb up 3, right 1, so the slope is 3 over 1. If I wanted to go from B to C, I would down 2, right 6, so that's -2 over 6, which is -1/3. These are also opposite and reciprocals. Now, another thing we can note is that we've got some slopes that are equal. AB and CD, they have equal slope. So are AD and BC equal. The slopes are the same. So what that means is, since our opposite sides have the same slope, they are parallel. So the figure is a parallelogram. The consecutive sides are perpendicular. Why? And this was a concept we had trouble with last semester. If your slopes are, perpendicular segments or lines have slopes that are opposite and reciprocals. So they're opposite in sign, and they are flipovers or reciprocals, however you want to say it. The proper term is reciprocals. I say reciprocals to try to get you to remember to flip them over. All right, so that means that we have perpendicular segments, which are right angles in the corners. That proves that this is a rectangle. Okay? ABCD is a parallel rectangle because they have right angles in the corners and opposite sides are parallel. Anybody still need this? Okay. To use the distance formula. Okay. Kenny, will you tell me what point A was? Okay, that definitely matters. Okay. -3, 0? I just need to jot these down so I can do this part without keep on looking back. Okay, Dariana, what's point B? Thank you. Okay, just trying to get people awake. Olivia, what's C? All right, C was at 4, 1, and then where was D? All right. I just needed those points because I didn't want to keep flipping back to that other page. All right, you've already got them in front of you, so you don't have to rewrite them if you don't want to. I mean, if you want to, you can. All right, they already found us the length of A to B. They did the distance formula. So they did -3 minus -2 and 0 minus 3 to get the square root of 10 after they squared those. All right, let's find B to C. So I'm going to do it the long way. BC, you can start with whatever point you want. The formula says x2 minus x1, so if I do B to C, I'd probably go 4 minus -2 squared plus 1 minus 3 squared. And then you can do this stuff in your calculator. That's actually 6 squared plus -2 squared. You just need to remember that when you square negative, you get a positive. That's 36 plus 4, so we get the square root of 40. Okay, I went kind of quick. Now, I want to show you a little trick. What was the slope of CD? Look back at the last problem. The slope of CD before we reduced it was 3 over 1. That's the change in the y over the change in the x's. The formula just says do the change in the x's squared plus the change in the y squared. You can do 1 squared plus 3 squared. That's the square root of 1 plus 9, which is the square root of 10. Now, the slope of AD, if we go back and look at it for a moment, slope of A to D was -2 over 6 before we reduced it. We'd have to use the numbers before they got reduced. -2 and 6. Those are the change in the x and the change in the y. So you could do the square root of, it was -2 and 6, 6 squared plus -2 squared. Guess what that gives me? The same thing as the last problem. So that's the square root of 36 plus 4. You get the square root of 40. So if you've already found the slopes, you can use those numbers to do the distance. Just don't use it reduced. You don't use the reduced numbers. Now, the opposite sides are congruent, so we got a parallelogram right now. All right, you see these numbers are the same. A, B, and C, D are the same size, and B, C, and A, D are the same size. So therefore, that's the opposite sides congruent. We got a parallelogram. Now, to figure out whether it's a rectangle, the diagonals need to be congruent, and those are segments AC and BD. So I'm going to take the point A and C, and I'm going to find this length. I'm going to start with the x's, 4 minus -3 squared plus 1 minus 0 squared. That's going to be 7 squared plus 1 squared, which is the square root of 50. And now I want to see if BD is the same length. So to go from B to D, I take the x's and subtract them. 3 minus -2 squared. I went from the D point with 3, subtracted -2. Now I'm going to do -2 minus 3. The y's. Oops. But when I subtract those, I get the square root of 5 squared plus negative 5 squared. And if you don't type that correctly, you're going to get 0, but that's 25 plus 25, square root of 50. So ABCD is a parallelogram because it has congruent diagonals. So ABCD is therefore also a rectangle. Okay, that was it on the ISN, correct? All right, so go to the packet, please. I'm going to jump right to the examples. We've already talked about the parallelograms properties and now the rectangles properties. A rectangle is a parallelogram with 4 right angles, and it's a special parallelogram. You have a few blanks at the top of your paper. You don't have to do all this stuff. Let's go to the examples. And I know I have some extra things in here. So we already discussed that it's got a lot of properties, has the same properties as the parallelogram. Okay, now a quadrilateral RUTS above is a rectangle. U to S, oops, that's a diagonal. I just looked at where it was. Okay, and RT, 7x minus 2. All right, those are both diagonals, which we need to remember that since the diagonals of a rectangle are congruent, that US is equal to RT. So let's plug in US 6x plus 3 equals RT 7x minus 2 and solve. I know a lot of you don't like the x's being on the right, but too bad. We're going to go with it. Bring down 3 equals x minus 2. Add 2 to both sides, and then get 5 for your x value. It didn't seem to do anything else but to find x. Number 2 example. Quadrilateral RUTS above is a rectangle, and angle STR, I gotta find that, STR is 8x plus 3. And then UTR is 16x minus 9. And what do those two angles do together? They form a right angle, which it says right there. UTS is a right angle, that whole thing. So we're going to add them. We've got 8x plus 3 plus 16x minus 9 is equal to 90. All right, let's combine our like terms. 8x and 16x, 24x. 3 minus 9 is minus 6, and that equals 90. Next step, add 6. We've been doing this algebra stuff all year. 24 times x is 96. Will you please divide 96 by 24? Okay. All right. Next, you will plug 4 back in so you can find the measure of angle STR. STR was 8x plus 3, so we need to do 8 times 4 plus 3. That's 32 plus 3, which is 35. So it'll be 35 degrees. If you're doing these with me as we go, you're probably going to be more successful in the long run than if you're just sitting there waiting for someone else to do the answers. ABCD is a rectangle, so we know it's a rectangle. Let's go with BE, which is 6y plus 2, ECE, 4y plus 6. Okay, now those are segments. What do we know about them? Are these going to be equal? Because the diagonals cut each other in half and are equal, then yes, these segments are all the same size. So we are going to set them equal. So 6y plus 2 is equal to 4y plus 6. Some quick algebra, get our x's on one side. 2y plus 2 is 6. I know you guys can do this, but subtract 2, you get 2y is 4. And then divide by 2y is 2. We should be getting faster and faster at doing our algebra equations, which I'm sure some of you are. I just go a little too quick sometimes, so let me know if I need to slow down. Okay, we're good finding y. 2. BC is 24. You can still keep the same figure if you want, because I think you can write 24 at the top without getting confused about what you wrote inside. And then the bottom 5y minus 1. Well, what do we know about BC and AD? They're sides of the figure. What do we know about them? Yep, they're congruent. Okay, so these are equal to one another. So I'll just go with 5y minus 1 equals 24 and get this algebra done really quick by adding 1 and dividing by 5. Okay, moving on. I think this is your number 3. Somehow this is numbered incorrectly. There we go. B to D, that's a whole entire diagonal. And A to C, oh, that's another diagonal. And those diagonals are congruent. So sometimes it just helps to make sure you look at the diagram, see that the diagonals, what those segments are. We know they're congruent, so we just do it. 8y minus 4 equals 7y plus 3. Subtract your 7y from both sides. Add your 4, and we should be done pretty quick with that algebra. Y is 7, but it did say to find B to D. So we got to go back and do B to D equals 8 times 7, the y value we found, minus 4. That's 56 minus 4, which is 52. Okay, now I am just doing examples for you. You may need to back up and look at them in a little slower fashion when you're trying to figure out how to do your problems. All right, number 4, A to B. Oh, that's a side, 6y, so I think we can do that right on that same picture that you have, even though I know I wrote on mine. I don't have mine written on. B to C is 8y. Oh, find BD. Well, wait a minute. They want this in terms of y. Well, I do know that if 8y is at the top, where else can we put it? Yeah, 8y can go down here. And we know that the corners are right angles. What do we know to get us to solve this right triangle? We've done it probably 50 plus times this year. What's the theorem? Pythagorean theorem. Yep. A squared plus B squared equals C squared. So 6y squared plus 8y squared equals BD squared. This isn't going to be as hard as you think. 6y squared is 6y times 6y. That's 36y to the second. 8y times 8y would be 64y to the second. And then BD squared. I don't know what that is. I'm just writing it. 36y squared plus 64y squared is 100y squared. And then how do we unsquare stuff? Take the square root of both sides. So that would give us 10y. Square root of 100 is 10. Square root of y squared is y. Square root of BD squared is BD. So that's the answer, 10y. BD equals 10y. I probably am not going to put that on a quiz or something unless it was like a bonus question, but it's not that it's not doable. We've done Pythagorean theorem. Okay, and then 5. It's got its own picture. Angle AED is 12x. Wait, where's AED? AED, right there. And angle BEC is 10x plus 20. What do we know about those angles? I hope so. If you don't know those are vertical angles, oh lordy, we've been talking about those so many times. Those are vertical angles and they are congruent. So 2x equals 10x plus 20. Go ahead and subtract 10x and divide by 2. So I got quick, x is 10. And then it said to find the measure of angle AED. Measure of angle AED can be found by substituting x in, putting in a 10 for the x. So that's 12 times 10, which is 120. Okay. So, prove that parallelograms are rectangles. You can prove that a parallelogram is a rectangle by using the slopes. To prove the consecutive sides are perpendicular. Make right angles. Or the slopes must be opposite and reciprocals for that to be the case. Example, 1/2 and -2. Or something like -2/3 and +3/2. Okay, those are examples. Or you can use the distance formula to prove the diagonals of a parallelogram are congruent. That would make it a parallelogram. Okay. So we're going to graph the quadrilateral and we're going to do distance formula. -3, 1 is A, -3, 3, B, 3, 3, C, and 3, 1, D. Now, this is a very nice problem for us to do because all these are horizontal and vertical segments. So this, so it's going to be a quick one. At least as far as finding the length, proving that it's a parallelogram first. So side BC, let's just count it. 1, 2, 3, 4, 5, 6. Length of BC is 6. We need it to be compared to length of AD. 1, 2, 3, 4, 5, 6. And I'm going to put that on the picture that those are 6. And then B to A is 2, and so is D to C. So I got that down. BA is 2. CD is 2. Okay, so we've got opposite sides congruent. Pen sticking. All right, opposite sides are congruent. So therefore, this thing is a parallelogram, right? All right, now we need to prove if it's a rectangle. It said we needed to use distance formula, so we want to see if the diagonals are congruent. So we want to know, is BD congruent to AC? So we want to find the length of BD and AC. Let's go use the numbers we have on our picture. Pythagorean theorem, 2 squared and 6 squared, basically is what we're doing. The square root of 2 squared plus 6 squared, or 6 squared plus 2 squared. That's 36 plus 4, we get the square root of 40. And then we can do BAC the same way, 6 and 2, square root of 6 squared plus 2 squared. Get the square root of 40. So diagonals are congruent. So the diagonals are congruent, therefore it's a rectangle. Or you can write, so it's a rectangle. And I think I just have one more to go over with you. Is that correct? All right, last one, and then I'm going to put up the shapes back there. You're going to help me. Quick graphing this. There's A. B's at -2, 3. 4, 5 for C. Oh, I don't think this one's looking too much like a rectangle, is it? And saying to do slope formula. Okay, so if we do the slope of AB, that would be up 1, 2, 3, right 1. Up 3, right 1. 3 over 1. I'm going to compare that to the slope of DC. That's also up 1, 2, 3, right 1. Okay, then I'm going to go find the slope of BC. To go from B, which is here, guys, to C, climb. Up 2, right, 1, 2, 3, 4, 5, 6. That's 1/3. And the slope of A to D is also up 2, right, 6. So the slopes are the same. We've got a parallelogram. It's only a parallelogram. Why? The slopes aren't what? They're reciprocals, but they're not opposite. Okay, they have to be the opposite sign. Okay, so this thing's only a parallelogram. Okay, the next part was your assignment that you're supposed to try the problems and be prepared with questions. Tomorrow, I will answer questions on the homework part, and we'll talk about squares.